Hello guys and welcome to another video with Cass on the Mizumo Games channel. And today I want to show you some simple ways of doing some hardware solutions using simple parts. So here we have just a LED and a button, and every time we click the button the LED turns on. Alright, we can also connect a switch to it, and if we run the simulation the difference is it's going to be on all the time. What if we want the button to simulate what the switch does? So let's get rid of the switch. It doesn't keep the signal. But one way of doing this is by using a latch, and a very simple one to build is to simply use NOT gates. So I can use a NOT gate in there, and I can have another button down here, a NOT gate that I will invert to this area in here, and then this guy is going to connect to this other side in there. So let's see what happens now. If we run the simulation, this thing is already on, and if I press this button it turns off and it stays off, and if I press this other button it stays on. So this is interesting because we are keeping the state of the system inside this little memory kind of thing built with two NOT gates. If you play Minecraft, this is also possible to do in Minecraft. Just use a pair of NOT gates connected to each other, and if you have the input on one of the sides, it will switch between states. This is interesting. What's happening here is since this guy is inactive, this will be active, and because this is active, this is inactive, so it cycles and locks the information in. Okay, but ideally we want to try and do all of that stuff using a single button and not two. Alright, this is one way to sort out this problem. Here we have an XOR gate and a NOT gate connected to the button, and here we have a table describing how this entire system works. So the way it's supposed to work is we have C for current, so the current state of the system, and P for the previous state of the system. So if we read the first two rows, it says that if the current state is a 0, so the output is turned off, and the previous state was also a 0, then it stays at 0. And if the input or the current state is 0 and the previous state was a 1, it stays at 1. Right, so basically if there is no input, or meaning if there is no click in this button, the system remains as it is, which is what we want. We want the system to preserve its previous state. So if there is an impulse in here, so if this is 1 and the previous state was a 0, it becomes a 1, and if the previous state was a 1, it becomes a 0. So this is where we invert things whenever we activate the input. So let's run the simulation in there. If we click the button now, it turns off and it stays off. Click the button again, it goes on and stays on. The problem is this guy is not exactly stable because, well, in the past when they first launched the game, there was some sort of delay here, which is very important for this setup to work. But now there's no delay in logical gates. This is very, I don't know, this is kind of unfortunate, because now if I hold the button, you can see that, yeah, it spazzes, or it doesn't know exactly what to do. So meaning if I click, sometimes it will not do things right. So you see sometimes it flickers, sometimes it's because it loops more than once, so it keeps switching states in there. So this is not really a stable or good solution. If I give it a quick click, yeah, it works. I have no idea how I made this work the first times. But it has the property, but you need to have a short pulse to do here. I would need to build a monostable, which I don't know how to do in this version of the game, because they basically removed delay from here. I need delay to create a monostable, unless well, maybe there is a way to create it without any delay. You guys let me know in the comments if you know how to do that. But other than that, I think we're stuck with this. Because I don't want to leave you guys hanging, I'm going to show you a proper solution like this. You can see that I'm using a microcontroller, so this is still a single component solution. But yeah, I can do, it doesn't matter how long I press the button for. So if I keep holding the button, it doesn't matter. It takes the input and then it changes the internal state no matter how long I press the button. I'm not going to explain how the code works. If you want to know how microcontrollers work, please check out my video on Introduction to Basic Microcontroller, which is basically me working this T flip-flop example. So that's going to be it for this video, guys. Thank you very much for watching. Feedback is always very much appreciated. Bye.